Hi, welcome to day 4 of 100 Days of Common Lisp. In today's day, the problem actually was quite simple in the original. It was to choose a random number from a list. So I decided to make this day about lists. Lisp being list processing. Lists are pretty much a central data structure in Lisp. So we have already seen this a few times now, so it would be pretty obvious to you. But the easiest way to create lists is using the quote, which converts whatever follows into literal list. But this is not really used everywhere because it's kind of like a constant and you can't really modify lists created like this. So instead, the real way to do it is to do something like this. So this is the way you normally create and use lists. So let's create a list right now. So I'm going to use def_var and use the syntax to create our list. Lists in Lisp are linked lists. We'll go more into details of how they work later, but that's just something to keep in mind when coming from different languages. Now, the most basic functions for a list are length, which is kind of obvious as is used everywhere. The other one is to get the nth item out of a list. So this is what that looks like. In many imperative languages, you have the square bracket syntax. You don't have anything like that out of the box. In Lisp, everything is going to be parenthesis based S expression. So this is how you have basic organization. Now you can also think about the modifying lists. So for example, if you want to change this list and make the first element something else. So what do you do that? How do you do that? So the setf is a special form. We have seen it a few times before to set variables, but the way it works, it actually can work with any data structure, any field. There is a lot of magic going on underneath, but what I mean is, if you do this, where you say you want to get the first element, the 0th element of the list, and set it to 10, right? So surprisingly, this works, right? This is not the kind of syntax you see in other languages, so this can be confusing. But just see what I'm doing here, right? So this expression here on its own gets the 0th element. In other places, that would just return a value, right? But here we are then using the same syntax with the setf special form to actually set the value. So this kind of structure repeats in Lisp in a few places for structures, for classes, and you'll get used to it as we go along. So because we have a linked list, you might be tempted to think about the push and the pop functions, and that is available out of the box. So if I do this, where I'm just pushing a variable, a number into the list, you can see it here, and you can similarly pop number out of the list. Now, I say numbers here because this list only has numbers, but because Common Lisp is dynamically typed, your Lisp actually can have anything else. It doesn't have to be the same type. So what I mean by that is, let's switch out or let's push a string into our existing list of numbers, right? So this is what it becomes, and you can see that you have this list now with a string and a few numbers. You can push other things in if you want, including nested lists, right? So I can create one more list here, which is something like a string and floating point number, and I'm going to push this onto the list, and you can see it makes sense. So in Common Lisp, everything is a list, including the code that we write. It might be becoming clearer to you because if I write any code, including the code that I just wrote, which is this, this is also a list, right? Except it's code when it's not quoted. So it's code right now, but if I quote it, it becomes a list again, where in your list we have a symbol push and another list with symbol, string, number, and so on. If you are used to functional programming, or if you have heard of it, then you know that some of the fundamental units in functional programming are map and reduce, and we have those things here too. So I can map a list. Let's say I need a function here, but I'm going to just use and create a lambda, right? So let's take something like this, where we want to like double the number. So what's happening here? We have a lambda here, which will take a single argument x and double it. And this is the function we want to apply on a sequence of numbers, right? So this is the list that we're going to pass. I'm just going to use a quoted list here. And you see that we have the output here as 2468, right? And this is the basic map function. So similarly, we can also do reduce. So we need a function here, which is, let's say we want to accumulate, right? So I can actually use the existing inbuilt add. I could have used a lambda here, but I'm just going to use the inbuilt add. And let's say we want to do the sequence, and this is what we are giving in, and this gets reduced to 1 plus 2 plus 3 plus 4, right? So these are the basic list related functional programming constructs. There are more, and we will see some of them as we use them in different places down the line. Now that we have seen all of this, the problem in the original course for this day was basically to choose a random element out of a list. So we have seen the required ingredients already. We have the length and we have the nth function. So the only thing missing here is random, but that is kind of obvious. So the function random just takes a single argument and picks a random number in that range. You can look more into random, but that's kind of an obvious one here. And now that we have seen the list ingredients, you can easily combine those to get the basically choose first get the length of the list, choose a random number within that length, and then pick that item from the list, right? So this is pretty obvious. So that's the basic of list. There are a lot more interesting data structures built on top of lists, like A lists, association lists, or P lists, property lists, but we will see those in later videos. But today I just want to mention one more thing. Just because lists are the most important data structure in Common Lisp, that doesn't mean they are the only data structure. So for instance, Common Lisp also provides arrays, right? And arrays as in contiguous location memory. And you can obviously use those to solve your problems as well. So we'll quickly look at arrays, which are actually quite more powerful than you would think, especially for a Lisp. So we can start with the make array function, and it asks for dimensions. So let's start with the simple dimension situation where we just have a single dimension. And if I just do this, we get an array here with some initial value, right? So now if you see this syntax hash, it's a special syntax being used to indicate arrays. So you can actually create arrays like this also, the way we created lists. You can actually quote and create an array with the hash syntax. Now, in languages which have arrays, because they are usually statically typed, your arrays are going to have to be of the same type. In Common Lisp, because it's dynamically typed, actually by default, these elements can be of any type, the most generic type. So what I mean by that is, let's start with this simple thing, right? Let's start with accessing array. So just like how we had the nth, we have the aref here. So, okay, we don't have an array yet. So let's do one thing. Let's override our a variable from before with a new array. that we are going to create here like we did before, right? So we have our a variable now pointing to this array, and like I mentioned earlier, a ref of the array and followed by the dimension, so by the element, so 0 is the first element. Because they're all 0, it's a bit confusing. Let's set it like before. So if we do the same thing like you saw with the nth, aref also, setf works the same for these things. So let's make it something else, right? So now if you look at a, your 0th element is 12. So you have the same pattern here to access an element and to set an element, right, with the aref. Now, what I was talking about earlier, because we didn't specify any type for this array, it is actually going to be a generic array of any type, which means I can do set the first element to something like this. This can be a bit confusing if you look at this, because we have an array, but it's actually of different types. If we look at the definition, so if I try to create a new array and use the same syntax we had before, but if you look at the documentation below, you see that we can actually specify the element type to be something, and we can also specify the initial element. So for example, in this case, I can ask for the initial element to be 10, right? And so what has happened is there's an error. Let's see what's wrong. We never specified the size of the dimension. So let's make that, and okay. So if you see here, this A is has these elements. Now you might think that this is an integer array because that's what this definition looks like, but because we specified integer type here, but that's not the case in Common Lisp. So this specification is not a static type specification. It's more of like a compiler hint that the compiler can use to optimize this array. So it's more of a performance thing, and it's not really a correctness thing. So what I mean by that is, in this case you can in this case you can set, like we did before, set the array's 0th element, which was earlier 10, to a string, and it actually works, right? It doesn't compile, I mean compiles correctly, it doesn't throw any error. So that can be a bit confusing. The array types can get upgraded to basically fit a more generic type and so on. So let's take a different example. If I create a new, let's create a new variable b, and let's make array here. This time we have the same 10 dimensional 10 number of elements, and we have a different element type. What we are saying here is we are asking for an array with element type an integer which is between 0 and 1, right? This is very interesting because this is kind of more richer type system, but again this is not statically checked. It's more of a dynamic type system, but we do have this option. We'll go more into types in the future separately, but for the moment, if I ask for this, what happens is this array is actually stored as a bit array, right? It's not, it has taken an optimal solution, and this array now, if you try to do what we did before, which is to set the array 0th element to something like hi, right? You're trying to set a string, it's still an array, but this time if you see, it's actually not going to work because the compiler has used an optimal storage mechanism, and hi will no longer fit in that story, right? But instead, if I just set it to 1, this would work. And if I look at the bit array now, it's the first bit is actually 1. You can have more richer things here. So what I mean is, if I go back to our B and try to do something like this, let's take a 5 element array this time, element type, and this time we do something like this, right? And so if you see this now, so if you look at this B, this is, you can't, I mean, you can't do it as a bit array because we have 3 options for each integer, right? So it's taken a different representation. So there is also this array element type function. So if I do this on this array, you'll see that this time it's used something different. So if I go back to our A array, so if I do this with the A array, you will see that the type here is the most generic type, which can store anything, integer or string. But this time we have the type as an actually unsigned by 2, which is the smallest size it should take to fit an integer with only 3 values, right? 0, 1 and 2. So this time if I try to do what we did before, so I'll take the array B and take the 0th element, and I tried to set it to something else, right? Like the integer 5. It's still an integer, but not within this range. I will get an error that it's not fitting this type. So basically, we do have some sort of dynamic type checking, but it is not as static or the way you expect it to work, like if you come from languages like C. Now, if you might have noticed, when I try to create arrays, there is also this dimension input doesn't have to be a single dimension. So if I do this, this is basically creating a 2-dimensional array, a matrix of 3 cross 4. And this is very interesting because now let's create a new variable and let's store a matrix. And as before, we have the aref for the matrix C, and now you see that you can actually have multiple subscripts. So if I do this, we get that element 0, 1. If I do this, you get an error because the array's rank is 2, but you have given a single element. You can also get the dimensions, right? So that's what I was looking for. Dimensions of C, and that's 3 cross 4. So the usual ideas. And this doesn't have to be, so we can take the same, let's do something. Let's make an array of a 3-dimension, right? So what I mean is something like this. And that's a 3D array where you can access each of the elements and so on and so forth. So we have seen a bunch of things around arrays. Just one more thing I'll add here. A single one-dimensional array is usually referred to as a vector, and there are some functions which work only on vectors. There are some functions which work on arrays of all dimensions. You have already seen there are some functions that work on lists, and interestingly, in Common Lisp, a string is actually an array of characters. So that's how. So all of the array functions would also work on strings, and so on and so forth. So there is also a set of functions that work on all of these, which you can think of as sequences. Uh, if you look at any of the Common Lisp references, so for example, I have this very useful cheat sheet which I found online, which has all sorts of documentation on different kind of functions for different kind of types. So for example, the make array which I was talking about, there is also the adjust array to change the size of your array, and aref lookup and so on. So there is also a bunch of sequence related functions which work on all of these. So things like every or concatenate. We looked at concatenate in the very first day where we concatenated strings, but that same function would work for all types. So we also have other functions like merge, fill, length, count, and so on, like reverse, finding, searching, and removing, deleting, and also the earlier function that we saw like map and reduce. So there are a lot of different things you can do with arrays and lists. So this video is more to give you an basic introduction into this space, and in later videos we will use arrays and lists for different purposes, and we'll get a better handle on things. I started this video with lists, but then I spent also some time on arrays, and this was by design because for a long time when I learned Lisp, when I started learning Lisp, I focused so much on the list angle of things. I didn't really pay attention to things like arrays, but then later I realized that that was a wrong thing to do. Just because Lisp is very good at managing and manipulating lists doesn't mean that it is also uh, not good at doing other things, right? So the point is use the tool for the job. There are times when you want to do pure functional programming kind of programming, and you can do that with lists. There are times when you just want efficiency or simple imperative loops, and arrays are good for that scenario. So maybe this is a broader theme because as a beginner, you don't realize and you just think of list as Lisp and Lisp as list, but Common Lisp especially has a lot more thing, lot more features, and you can use all of them as and when you need for your programs.